Hey, this is Gabriella Gentry, and this is my review of Feeding in Fear: Indirect Effects of Predatory Fish on Macrophyte Communities, mediated by altered crayfish foraging behavior. There were three authors: Tyler Wood and Paul Moore both held PhDs and worked as professors at the Bowling Green State University in Ohio. Rosemary E. Kelly also held a PhD but was a professor at the University of Michigan. They got funding from their respective universities, Building Strength Award, and the Graduate Student Endowment Fund. A little bit of background is that predators are thought to have large effects on communities, either by their foraging having effects on the food web or how others will interact with them. And we know that there's a change in prey behavior with the presence, but we want to know what kind of changes those are. And of course, this can only be done if prey can actually sense the predator before they are eaten. So we want to see how that works. Their main hypothesis was that the predator presence would reduce crayfish's consumption of plant life, and that they would also rely on one single food source, which would not only diminish the diversity of resources, but it would definitely construe the normality of the food web when it comes to anything else that would be using those varying plant species. They chose the rusty crayfish because of its sensitivity to smells, but also its impact on plant life, as that is one of its main sources of food. And then the predator and the macrophytes that they chose were largely based on their natural occurrence with the crayfish. They chose the largemouth bass not only because of that, but because it has such a strong smell, and they thought that that would play in well with the crayfish's sensitivity. The macrophytes, or aquatic plants, that they chose were American waterweed, muskgrass, and northern water milfoil. And of course, we said that they were naturally occurring. They actually pulled the crayfish and the plants from the same Michigan lakes, so they were sampled together. The crayfish were labeled with non-toxic pins, and the plants were dried and weighed before and after the trials. They dried the plants with one of those salad spinners, is how they dried them. I thought that was neat. They got the bass from a farm rather than actually sampling for them, and they fed them crayfish pellets, which they thought would help with their overall smell. They performed 80 trials with 4 different treatments, and they set up 8 identical tanks that had water and gravel from a nearby stream, so they had it set up as realistically as they could. They used cameras for 24-hour observations, and what they really wanted to look at was how long they spent in their shelter area hiding and how long they spent in the plant area eating. They also wanted to record how many times they transitioned back and forth from these two areas. The results were that they consumed nearly double what they would in the presence of bass than without. They ate significantly more waterweed than they did the other two, but muskgrass was also greatly reduced in its biomass. Water milfoil didn't really show much of a difference, but they didn't eat less. And the other two were significantly more than the water milfoil. Another thing that they noticed was that the frequency of transition dropped by about 20%. So they were moving back and forth less. However, they spent more time foraging and less time in the shelter when in the presence of the bass. So this was pretty contradictory to what they were expecting. They really expected them to have more time in the shelter, to be hiding in the presence of bass. And they did, however, they showed plant preference. So that was part of their hypothesis. And part of the reasons that they thought might have been why they were spending so much more time eating and why they ate so much more than normal was the overall stress. Basically, that they were stress eating. Uh, when you're in that fight or flight for so long, it kind of raises your metabolic needs, so they needed to compensate for that. On the other hand, or another reason they thought they might have been doing that so much was that if they made themselves so large, they would be too big for the bass to be able to eat. And they thought that since it was only smells, that could have been why they saw the reaction that they did, that if they did the trial again, they might add an element of them actually seeing the fish to see if that would produce a completely different result. Some of the implications of what this study saw was that in the presence of bass, it would limit the overall plant life, that they would be eating double as much as they normally would with the smell of them, and that their preference would greatly bring down diversity, especially since they were choosing two main ones over another that would potentially wipe out those two species. And this overall would have a lack of food for invertebrates as well as others. So it would just greatly reduce the resources. But this plant life also provides a home for algae, bacteria, protists, which is extremely important for the overall functioning of freshwater systems. Credibility of this article, it was pretty credible. It was published in 2018 in the Freshwater Biology Journal, which had a impact score of 3.84, and it had a huge editorial board. It was all doctors and professors. It was a huge list. I'm pretty sure it was over 30, and they were all from, there was 20 different countries that these people were from. So it really eliminated any kind of locational bias that they might have. As far as the actual article goes, they had lots of trials and lots of precautions, so that makes it, to me, pretty credible. They even did things like they rotated the plants to ensure that there wasn't location bias as to what was closest to their shelter. They allowed the water to flush out between trials, so there wasn't any kind of cross contamination with the smells. And they used 160 different crayfish, so they had a decent sampling size to have a better overview of how the entire species might act. And I found this to be really relevant to studies in population control. I read another article where they tried to use bass in maintaining invasive crayfish species. But when you're doing something like that, you might want to take something like this into account as to how the addition of these predators are going to affect your naturally occurring plant life. Thank you.